So we've got this study guide to get us ready for the test. And remember, this test is over being able to represent lines, circles, and ellipses in parametric form as well as in standard form. So we start off with lines. And so let's look at the approach. The first thing we're going to do when we want to write the equation for a line is we take note of the slope. And notice here, what I'm going to do is I'm going to go over 1, 2, 3. So that's the run. That's how far I move horizontally, and up 2. So my slope is going to be 2/3. See? Because I go over 3 and up 2. Now, what I'm doing with these is what I'm doing to write my equation for the line is I'm looking at this thing. I'm looking at y equals x, and I'm transforming it. In other words, I'm going to change the steepness. So instead of y equals x, I've got 2/3 x. And that's not enough. I want it to pass through the point -2, 1. So I'm going to say x minus a -2. That's going to be x plus 2. And then I'm shifting it up 1 unit. So there is the first thing. That's an equation for this line. Now, I also want an equation for the line that's perpendicular to this one. Well, all we have to do is invert, take the slope, invert it, and change the sign. Or not invert it, but reciprocate it and change the sign. Everything else is the same. So here's an equation for the line. Here's an equation for the perpendicular. Now, we went beyond that and we said, okay, well, let's get a set of parametric equations for the line and a set of parametric equations for the perpendicular line. So this makes the 4. When I say find the 4, I'm talking about an equation for the line, an equation for the perpendicular line, and then the parametrics of those. So when we talk about the parametric form, remember we need a vector. And one vector that we could use would be just over 3 and up 2. We could use that vector. And then for the perpendicular vector, we could use 2, -3 if we wanted. Just swap the ordered pairs and change one of their signs. But what might make it easier for us if we just do this? If we say, okay, the vector is going to be 1, whatever the slope is. Okay? In other words, remember, so if you look at this, we're saying, okay, for every unit change in the x direction, this is the change in the y. So if we change a unit in the x direction, we go 2/3 in the y. And then we have the perpendicular slope, which is going to be 1, -3/2. See? So it's just like this. It's just like here's this, and then we've got the slope over here, -2/3, or -3/2 right there. So now we have this. We have x is equal to, first of all, t minus 2. See, we've got the vector and the point. And then y is equal to 2/3 t plus 1. See, I just get this point. So what we're doing is we're saying if we've got a vector, AB, remember we're saying AT plus the point. And y is equal to BT plus, the y coordinate. Now for the perpendicular, we have x equals, now I'm using this vector, we have t minus 2, just like the previous, but y is equal to -3/2 t plus 1. Okay? So there it is. There's the 4. We've got this one 1, 2, this one 3, and this one 4. Those are the 4. Okay? So let's look at this other one. So I start off with y equals x, but I'm going to transform it. I'm going to use the slope. So this time, notice, I'm going down 3 and over 1. See? 1, 2, 3 over 1. So the slope is negative 3 over 1. So I'm going to not have y equals x, I'm going to have y equals 3x. But I'm also shifting it over to the right 2 and down 2, like that. And then for the perpendicular, I've got negative 1/3 x minus 2 minus 2. Okay? So notice here's the slope, negative 3. The perpendicular slope is going to be 1/3, like that. And actually, this should be a negative 3 here. And this should be a positive 1/3. Got that backwards. Okay. Okay. Now, for the parametric, we've got x equals t plus 2, and the y is equal to negative 3t minus 2. For the perpendicular, we've got x equals t plus 2, and y equals 1/3 t minus 2. So notice how the slopes and the vectors match up. So the vector up here for this one was going to be 1 comma the slope. Okay? The vector down here is 1 comma and the slope. Okay? So that's how we deal with these lines. Then we move on to circles. And with the circle, remember, we have a standard form, which is x minus h squared plus y minus k squared equals r squared. And for the parametric, it would be x equals r cosine t plus h, and y equals r sine t plus k. So let's see what the formula is here. So we've got x plus 2 squared plus y minus 1 squared equals, let's see what the radius is. 1, 2, 3, 4. So 4 squared is 16. And then the parametric, x equals 4 cosine t minus 2, and y equals 4 sine t plus 1. And notice, when you look at these, this plus minus 2, it's exactly what the x-coordinate is for the center. The plus 1 is exactly. It's when it's in the parentheses that it's the opposite. Okay, so let's look at this other one. We've got x minus 3 squared plus y minus 3, or plus 3 squared equals, let's see what the radius is. 1, 2, 3, so there'd be 9. And then you have x equals 3 cosine t plus 3, and y equals 3 sine t minus 3. Okay, so there it is. Now, let's move on to the ellipses. Now, remember, the ellipse goes like this. You have x minus h squared over a squared plus y minus k squared over b squared equals 1. Okay, the quantity. X minus h quantity squared, y minus k quantity squared. Now, the parametric form would look like this. X equals a cosine t plus h, and y equals b sine t plus k, where hk is the center. Okay, so let's see what this looks like. So we have an ellipse here, this part C, and it looks like right here is the center. So I've got to figure out what that is. So I'm go 1, 2, and then 1, 2, 3, 4, 5, 6. So it looks like that center is 2, negative 6. So here we go. We've got x minus 2 squared plus y plus 6 squared equals 1. Now let's see what goes on the bottom here. We go over on the x. Let's see what goes under the x. So parallel to the x-axis, we go 1, 2 from the center. So that's going to be 4. On the y, we go parallel to the y. 1, 2, 3, 4, 5, 5, right? So that'd be 25. See? I square it. So x is equal to 4 cosine t plus 2, and y is equal to 5 sine t minus 6. Yeah. So just be sure you have these numbers. Remember, in the parentheses, you're going to have the opposite. 2, negative 6 becomes negative 2, positive 6. But in the parametric, this is exactly the center, 2 and negative 6. Okay, so let's look at this other one. Now, the scaling on this you have to be careful of. So it looks like, let's see what the center is. It looks like maybe this is about the center right there. Let's see. And it looks like every 2 little notches is 1. So let's see here. This is 1, 2, 3, 4, 5, 6. Looks like I go 6 that way and 1, 2, 3 up this way. So let's see what the center is. Looks like the center is, let's see here, negative 5 and negative, what is it, negative 8. Looks like that's what it is, right? Yeah. So it's going to be x plus 5 squared over something plus y plus 8 squared over something. Now let's see what goes under the y. Looks like 1, 2, 3, so that's 9. Over here, 1, 2, 3, 4, 5, 6, so that's 36. So then we have this. We have x is equal to 6 cosine t minus 5, and y is equal to 3 sine t minus 8. Yeah, because this right here is negative 5, negative 8. Yeah, that's it. Okay. So then we get into these last ones where we're going to have to complete the square because we don't have it in the form that we like it, where we can easily see what the center is. So I look at this first one. I've got x squared. I'm going to group my x's together, group my y's together, and move everything else to the other side. Now we recognize that this is going to be a circle because the coefficient of the x squared and the y squared are the same. So I take half of this 6 and square it. Add it to both sides. Take half of this 4, square it, add it to both sides. And then I can rewrite. It's going to be x, and what's the next thing? Well, whatever this is. So it's x plus 3 quantity squared. Then y, and whatever this is, quantity squared, and then equals 16 on the other side. So there's our circle, and then the parametric is going to be 4 cosine t minus 3, y equals 4 sine t minus 2. Because notice that the center is negative 3, negative 2. Okay, on the next one, okay, so we do the same thing. We group the x's, group the y's, half, and square it. Add it over here. Half of this, and square it. Add it over here. So let's see what we've got now. We've got x minus 1 squared plus y plus 4 equals, looks like 36, right? Yeah, so the center is 1, -4, and it looks like we've got x equals 6 cosine t plus 1, y equals 6 sine t minus 4. Yeah, that's it. That's the parametric. Now, in all of these, t is going to go from 0 to 2 pi. We haven't been thinking much about that, but really, when you write the parametric equations, you need to put the boundaries for t. But okay, now let's look at these last two. These two look like ellipses because notice that in front of the x squared over here we have 9, and in front of the y squared we have a 4. So we have to be mindful that, okay, this is going to be an ellipse, and this is going to be a little bit different form than the circle. So let me group the x's together. Okay, so here I go. But what I'm going to do, I'm going to factor out the 9. I'm going to group the y's together, but I'm going to factor out the 4. Now, so be careful. Now notice, so dig what I did. I factored out the 9, and I've got 9x squared minus 36x. Okay? Now, I'm going to take half of this -4, square it, and add a 4 right there. But realize this. Yeah, I wrote a 4 in there. But really, to this side of the equation over here, I did more than that. This 9 is lurking, and as soon as I wrote the 4 in there, that 9 gets multiplied by the 4. So really, what I did by putting a 4 in there, I added a 36. So I need to put a 36 over here. Now this gets a lot of people. They forget to do that. Now look at this. I'm going to take the -6, square it, add a 36. But I've not just added a 36. I've added a 4 times the 36. So I put a 144 over here. So now I can rewrite this whole thing. 9 times x minus 2 squared over something plus 4 times y minus 6 equals 36. Now the last thing, since it's an ellipse, we want a 1 over here. So I'm going to divide through by 36. And I get 9 over 36, that's just, 1 over 4. Okay? And then y minus 6 squared over 9. Yeah, like that. See? I've just reduced this fraction, 4 over 36. Now, let's look at the parametric form. X is equal to 2 cosine t plus 2, and y is equal to 3 sine t plus 6. Yeah. Okay, the last one. So I get my x's, factor out the 16. There's nothing to factor out than the y's. Thank goodness. Makes it easy on us. Okay, so I take half of this and square it. Now remember, you got to watch your bad self, because the tendency is, oh, now I added a 1 there, I'll add a 1 to the other side. No, back it up. 16 times 1 is what you added. So you got to put a 16 over there. Now over here, you take half of this 4. So I got to add a 4 over here. Okay, yeah. So dig what you got now. You've got 16 times x minus 1 squared plus y plus 2 squared equals 16. If you divide through by 16, what you get is you get x minus 1 squared over 1, and then y plus 2 squared over 16 equals 1. There's your equation. Now for the parametric, you've got x equals cosine t plus 1, and y equals 4 sine t minus 2. There it is. Yes. Now, so that's the whole study guide. So if you have any questions, just let me know.